Hello everyone, welcome back to another video of this Veda series. So let us continue with the third module, and for that let me open the site. Okay, I'll go to I'm here in the documentation page, and let us go to the module 3 string modules. So let us see about the string modules and string functions today. Let me open the project file and hit on CMD. Then our shortcut. Then let us keep it parallelly side by side. Okay, and first let me create a file as class3 class3.vd. vd is an essential extension for this whole programming. And let us understand what a string is first. A character stream or a single character which is enclosed in between two single quotes is known as a string. So even if it's a character alone, its type will be a string name, and let us print the t. So it will be a string. Let us run this program. Veda class 3.ved. Okay, let us run this again. See, it is a string. So be it a string or a character, it will assume it to be a string. So let us first open the documentation and search for the methods. So first uppercase. So let us convert the name to uppercase. And how are we going to do it? Using the method uppercase. You see name equals to name to uppercase, and let us print the upc underscore name. See, all the characters have been converted to uppercase. So, and now the next method is lowercase underscore name equals to let us convert the upc underscore name to lowercase. So the camel case over here is very important, so you can get the essence of Java programming language. Let us clear this and print it, and see, you can see here. And the next method would be capitalize. So what is a capitalize actually? So the capitalize is a method which converts a string to title format. Okay, so lc underscore name to caps is the method. Print title, and let us run the program. See, the first character has been converted to a capital letter. And the next method is length. We can even get the length using the method name dot length. So let us print it length, and it should return 5. See, here is 5. And the next method is get binary. We can even convert the string to a binary. So name underscore binary equals to name dot get binary. Print name, get name binary. So if you are supposed with this term binary, a binary is a state representation for retaining the information in the systems. So we can even convert the name to hexadecimal using the method name.getHex and name.getOct. So getHex is the hexadecimal representation, and getOct is the octadecimal representation of the string. Name.oct. Let us run it. See the last two lines, and the next method is getHex getOct trim. Okay, so we can actually remove the redundant unwanted redundant spaces from this 1 2 3 4 rohit 1 2 3 4. So let us first calculate the length equals to name.length. Let us print the length, and it will obviously return 13 because we have added 8 more spaces. So if we want to get rid of this extra spaces, we can use the method trim. We have actually left trim and right trim. So first remove the left redundant spaces using the ltrim method. So name equals to, I'm updating it, name.ltrim, and I will calculate the length again and then print the length. See, 13 minus 4 is 9, and then I'll repeat the same for the right R trim. After that, yeah, it is 5. So instead of doing this L and R, let me comment out this. Let's comment with this. So this is how you comment in Veda programming language. We can directly use the method name equal to name dot trim to remove all the redundant spaces from the method. So let us first calculate and print it. Okay, let's calculate. Length equals to name dot length method, print length. So it is supposed to return 5. Yeah, see, the redundant spaces have been removed successfully. Then swap case. You can even swap the cases. Let us take the example of title. swc underscore name equals to title dot swap case. Let us print this swc name. So what it does is it actually swaps the case, small to capital, capital to small. And then we have the reverse method, rev underscore text equal to swc underscore name dot reverse. And then let's print this, print rev text, and it's supposed to reverse the whole string and return. This is it. And then we can actually convert the type manually. Num equals to 1977, and it is a string basically. So you can even check the type using the function num, and the type is string. So you can actually use this num equals to num dot to integer, and then just run it. So you will get integer here. So this is typecasting. And we do have encrypt and decrypt, which uses RASM internally, RASM algorithm internally. RASM is a security algorithm which provides advanced encryption. So it is basically my algorithm. So let us use it. Let the message be hello, how are you? So let encrypt it. enc ms equals to ms encrypt text. So you can encrypt this using the method encrypt text, and let us print it. enc, let us clear this and run this. So this is the encrypted message. See, the beauty of this algorithm is every time you run it, it will actually generate a new encrypted message. See, see, this is different from this. That's the beauty of my algorithm. So let us copy this and anc equals to, let's paste it over here, and let us try to decrypt this using the method decrypt. So dc underscore text equals to enc dot d cry decrypt text, print dc text, and the information will be returned as it is. Hello, how are you? I hope you liked this and enjoyed this video. I'll be making more such videos, and please like, share and subscribe to my channel, and see you next time.